My name's Joe Rinehart. I am the boot camp delivery manager for Cisco Training Boot Camps. Anybody heard of that before? Well, I'll do my best Liam Neeson impersonation. So we have this 9-day training experience. It's designed to build up a particular set of skills very quickly. That's really the commercial, but I don't. Bullwinkle's the only one I can. Anybody remember Bullwinkle? The sea, Cisco. That's the end of my impersonations. Anyway, I'm going to talk to you today about ACI. So be prepared to fall asleep. Just kidding. All right. So we're just going to, for the next, 20, 30 minutes, we're going to try to cover a little bit on ACI. I'm just going to do sort of a basic intro. And instead of just diving right in, I'm going to go over something that's familiar. Anybody done Nexus 7000s before? Yeah, so this will be perfect. So we'll use that as kind of a jumping off place into something new. And we'll talk about the whole logical constructs of ACI, some differences between the examples because it's an analogy, it's not perfect, and then just some wrap up. All right. What does ACI stand for? Well, according to Cisco, it's application-centric infrastructure. I started with the product when it was the 1.0 version of code, which is a lot like, Microsoft's every other release of, Windows. And so it was really kind of a tough experience. And it was a big uphill climb for me because I didn't understand why they were doing some of the things that they did. So I came up with an acronym for ACI. A lot of confusing information because it seemed to be contradictory. I was used to MAC addresses and VLANs and routing, and then it's like, but the VLAN's not really over here. And then a whole new set of names for things. So I just felt like my head was spinning. And if there's a secret to learning ACI, learn VXLAN first, then learn ACI. Can you guess what I did? I learned ACI and then did VXLAN. I could have saved myself months and brain cells, but it kind of helped me able to explain a little bit better. But really, ACI, this is kind of another acronym, is really an evolution of networking. How many of you are using 10 meg Ethernet? Dial-up. Frame relay. We don't because we've evolved beyond that. These technologies have been displaced and replaced by something else. And ACI is really an evolution of networking in that we can virtualize aspects of the network in a way we couldn't before. So even though it can be a little intimidating and even a little disorienting at first, it really is a step forward. All right. I have found that when you're trying to jump into a new topic, it helps to compare something that you already know. And so I'm going to use the Nexus 7000 VDCs as an example. It's just a way of review. So when you create Nexus 7000 VDCs, you create logically separate switches to the point where if you want one to communicate with the other, you have to cross connect. It almost looks like you're creating a loop in the switch, but they're logically separate switches. And you can have either 4 or 8 depending on what supervisor you're using. And when you create them, they're completely isolated from one another. And of course, you create it manually. Isn't that cool animation? That was worth the whole talk, right? And then once you've created it, you go in and you create the associations with interfaces and things like that. And when you use an interface in one VDC, can you use it in another VDC? Nope, that answer is incorrect. Would you like to try again? No, you can't. It can only be used in one spot at a time. And then you configure the various things. And what do you configure? Well, you configure a host name, VRFs if you want to use something other than the default VRF, VLANs, interfaces, networks, routing, out-of-band management, pretty much everything you can think of on a normal switch. Now, here's the kicker. Different VDCs, exact same configuration. Because they're isolated and they don't see each other, it doesn't make any difference. You could literally duplicate everything and it would be the same. And again, they don't see each other. They're separated by the contexts. So if you look at kind of what we were talking about before and put it sort of in a logical format, this is kind of one way to look at it. So you got all your VRFs, VLANs, interfaces, and all these other things here. And we could probably simplify it this way a little bit. So Nexus 7000 VDCs, you create separate switches, you populate it with resources, you can use it just as if it was a physically self-standing switch. And ACI is doing something similar. It's just using a different mechanism for it. Now, I'll be honest, when I first got into ACI, all that terminology threw me off. And it didn't help that it seemed like some of the terms changed every week. First, it was a private network, then it was a context, and then they finally called it a VRF, and then it suddenly made sense. But let's think about the elements of ACI. The first is a tenant. In a lot of ways, really, tenants are like VDCs. Think about them. They're separate. They can't communicate without some special kind of arrangement for communication. And you could literally put the same configuration, IP addresses, everything else, and they'd never see each other. So it wouldn't matter. And in this example, I've switched to a different configuration, but the idea is the same. A tenant provides logical isolation, just like VDCs do. And you could have overlapping subnets and all kinds of other things, even the same names for everything if you wanted to. And obviously, you can create multiple tenants just like you can create multiple VDCs in a Nexus 7000 switch. Now, VRFs. Do you know the difference between a VRF in ACI and a VRF in NXOS or iOS? There really isn't any. They do the same exact thing. It's a layer 3 routing instance. You're creating a separate routing table. You can assign interfaces to it, the whole 9 yards. The only real difference is this. When you go into an ACI mode switch and you do show VRF all, you will always see the tenant name first. That's really the only difference. Everything else about it does the exact same thing. So tenant, VRF, and by the way, they live inside of one another. So the way I did this diagram is for a reason. Have anybody seen the Russian nested dolls? You start out with the big one, you end up with the really tiny one. It's exactly the same way. These are all nested. The tenant is the big container, and everything else gets progressively smaller inside. With the VRF, you have what are called bridge domains. So a VLANs are layer 2 construct in traditional networks, and they've been around like since forever, right? Or it seems like it anyway. Well, a bridge domain does everything a VLAN does. It's broadcast containment, it's layer 2 forwarding, and it functions almost identically to a VLAN, but you can't say it's exactly a VLAN. In fact, it's a VXLAN segment. How many VLANs are there possible on a switch? 4,096, depending on the model. Do you have extended range VLANs? Do you not have extended range VLANs? Really, that's the upper end. With VXLAN and ACI, you have 16 million. Everybody gets the reference, right? Very evil. And it creates this through a network overlay, which is why I said VXLAN really gives you kind of the idea and the framework of how ACI operates. One of the bigger differences is you have some sort of an orchestration appliance that's doing all the work, but you're creating overlays. I have a YouTube talk on VXLAN that kind of steps through all this and it's also on CLN if you want to watch it, it could be helpful. So tenant, VRF, bridge domain, and bridge domains have subnets. When you create a subnet for a bridge domain, it becomes the default gateway for everything else that's associated with that VXLAN segment. So in this case, you've got 1111. It's a /24. You could have .2, .3, .10, however many else, and the default gateway would be that .1. And basically what it does is it creates a VLAN interface or an SVI, just like we're used to on a Nexus switch. So if you do show IP interface brief, which you can still do on an ACI mode switch, you'd see basically the equivalent of an SVI. How many subnets can be primary on an interface in NXOS or iOS? 1. If you create another primary subnet, it erases the first one. How many secondary ones can you have? I don't know what the theoretical limit is for secondary addresses. You just type in secondary and you can add a whole bunch. ACI works the same way. You have one primary subnet and then however many secondary subnets you want. So it's very similar in that way. When you do this, and this is part of the magic of VXLAN, is it becomes an anycast gateway. So we configure something like an Nexus 7K VDC. It lives on that VDC on that switch. In ACI, it lives on all the switches, which was hard for me to get my head around at first. But think of it this way. One switch with multiple line cards, right? Think of ACI. The ACI fabric is just a switch with multiple line cards. It's one unit. You do everything within that unit instead of looking at separate distributed switches. You still with me? All right. And you can add endpoints to the switch, which is what's coming up next. Now, application profile doesn't really have any kind of correspondence to things that we're used to, but it's really just a container that holds endpoint groups, which I'll talk about now. Endpoint groups, kind of at their basic fundamental function, is they are connections. So when you connect a server to a Nexus 7K switch, it is a connection. Works the same way in ACI. So if you've provisioned a port, you have a device attached to it, is a connection. If you create an L3 out, that subnet is another form of connection. So just think of endpoint groups as a group of connections. There can be 1, there can be 5, there could be 10 contained in there, but it's the same idea. And usually you group them around common requirements. So you might have servers in one, you might have database servers in another, web servers in another, and so forth. And one of the more common ways that you use this is you map an EPG and it has a layer 2 VLAN associated with it. VLAN's in the outside world, VXLAN inside the ACI world. But you do this in NXOS, switch port mode access, switch port access VLAN, name the VLAN, and it's going to do the same kind of thing as it does in ACI. And honestly, the server or endpoint doesn't have any knowledge that all this stuff's going on in the background. To them, it just looks like it goes here, it goes through, it comes out the other side, and the data flows. End of story. Big important point. Within an EPG, all the connections inside of that can communicate by default. If you don't want them to do that, you need to put them in separate ones. So you're trying to establish security policies where devices can't communicate, you don't want to put them in the same EPG. There are a couple of features you can turn on that change that behavior, but by default, out of the box, everything can communicate. But to a different EPG, you always have to have a contract. And a contract is a lot like an access list. You're defining what traffic can flow and what traffic can't. But if you don't have that between them, you won't get any communication. All right, so quick review of access lists. Access lists contain 3 things. The first thing is match criteria. What are you trying to identify? In this case, it's a protocol and ports, or just IP addresses, as you see here. Your match criteria, number 1. 2, actions. Once you've matched it, what are you going to do with it? Are you going to permit it? Are you going to deny it? Are you going to redirect it? And then you have direction. How many times can you apply an access list to an interface? Once per interface per direction. 1, 2, and you're done. But that's how we do packet filtering. Contracts, even though they function differently in some ways, same exact thing. Match criteria. We call them filters, but it's the same thing. Actions, permit, deny. And then labels. This consumer provider thing drove me nuts for a long time, because the explanation I heard is, well, you know, the service, it's being served on this side and it's being consumed on this side. And that was like saying, just repeating the same thing, and it didn't make any sense. And then I finally found the Rosetta Stone for it. Source and destination. Honestly, it doesn't get any simpler than that. Does it matter what port you're communicating with as far as source and destination go? Yeah, if you pick a random port on one side and you're sending it that across, and that's only going to be, the device is going to be listening on like port 23, port 80, whatever. It makes a difference. And that's why this whole consumer provider thing works. It's as simple as that. But you have to have that relationship. Does source to source work? No. Does destination to destination work? You have to have this inverse relationship to source and destination, just like consumer and provider. Otherwise, it doesn't work. Believe me, if there are mistakes to be made in configuration of ACI, I probably made all of them. Can you see the spot on my forehead from banging my head on the table? All right. So really, when you kind of look at these sort of new concepts, they can be a little confusing, but if you compare them to something that you know, they make a little bit more sense. But please don't think for a second that they're exactly the same. So if you walk out today saying, well, Joe said that VDCs and tenants are exactly the same, you're gonna get more confused than I was. So I just want to point out some of the differences. So VDCs, single chassis. There isn't a concept in VDCs of going across multiple chassis. In ACI, remember, multiple line card switch is what the fabric's like. It's going to live across all of those. In VDCs, you get 4 or 8 depending on your supervisor type. In ACI, you have numerous instances. Here's one that I find kind of interesting. In NXOS and an iOS, you have a default VRF. If you don't put whatever, a different VRF, and you don't assign another interface to it, it goes to the default VRF. End of story. There is no default VRF when you create a tenant in ACI. You have to literally create it. So tenant, then right-click VRF, and then bridge domain and so forth. But you have to define it. 7K VDCs, you have to physically connect different VDCs to communicate. And the way for tenants to communicate is either through the common tenant, which we're bonding on the scope of what we're talking about, or you can use something VRF route leaking, but it requires some special kind of intervention for it to work. NXOS, distributed, ACI, centralized. And 7K's only been on the NEM at 7,000. And for years, I was asking, are we going to do VDCs on the 9,000? And the answer I would get was, it's not currently supported, which was vague enough to say maybe it will be at some point, or maybe it won't. And I finally got an answer out of someone a number of years ago, and they said they wanted to use VDCs on the 9K because it's, and I quote, messy. But the 9,000 is also the only switch that ACI runs on too. So there's some, continuity there. VDCs, you're configuring on the CLI of the individual switch. With ACI, you're doing it in the GUI. And the GUI can kind of throw you off. I'm saying this at Cisco early on, we kind of had a fuzzy history with GUIs. I can tell you the 1.0 version of code was rough. It's a lot easier now, but you'd pretty much do all the configuration there. Either the GUI or the CLI. You can do CLI in the configuration of the controller, or you can use APIs, which of course is the wave of the future. You spend about 20 minutes in ACI, you'll be asking yourself, why don't you want to automate? All right, so just wrapping up. ACI can seem strange at first. Can we agree on that? I mean, when you're a dyed-in-the-wool VLAN, VRF, longest prefix match engineer, it kind of does this to your brain. But there's more alike than different than we might think. There's like the Nexus 7K to ACI. It gives you an idea that we've been doing this in a different form, and you can make the transition. ACI uses a series of logical constructs just like VDCs did, but they're not exactly the same. And we're currently on the 6.x version of code. I think it's going to hang around for a while. All right. Thank you for coming and listening to this today. I hope this kind of maybe made this a little clearer. So instead of it being all kinds of confusing information, you can wrap your head around a little bit. Thank you so much for being here today. Is there a drawing or anything? Okay, before everybody goes.